Alright, let's finish out the notes here. So this third example says find the equation with vertices at positive and negative 4, 0, and foci at positive and negative 5, 0. So I always like to start by graphing this information. So my vertices are here and here, and then my foci are here and here. Okay, so if we're thinking in terms of an equation like this, x minus h, well, I guess first of all, we need to figure out if it opens left and right or up and down. Well, if the vertices and the foci are on the x-axis, it opens left and right. Therefore, x will be first in my equation, or x will be positive. So x minus h squared over a squared minus y minus k squared over b squared equals 1. So right off the bat, I can get the center is going to be at 0, 0. Halfway in between the vertices or halfway in between the foci. Now, so I can go ahead and fill that in. So x minus 0 squared over something minus y minus 0 squared over something equals 1. Well, I can already see the distance from the center to each vertex. That's a distance of 4. So 4 squared is 16. Now, I don't know how far up and down I have to go. I need to solve for that. So I need to use my a squared plus b squared equals c squared idea, where c is the distance from the center to each of the foci. So I'm going to have 16 plus b squared equals, now c is 1, 2, 3, 4, 5. So 5 squared is 25. Subtract the 16 over. Take the square root, and we get that b is equal to 3. So in terms of my equation, b squared is 9. In terms of my graph, how far up and down I'm going is 3. So remember, this creates a box that we're going to use. Okay, now in this box, I am going to draw diagonals as my asymptotes. Oops. Okay, so the diagonals of this box are my asymptotes, and then I can sketch my hyperbola. So I know that these are my vertices, and then my parabola is just going to kind of follow along these asymptotes here. So this is what my hyperbola would look like, just these red arcs. All right. So I guess we could simplify the equation a little bit too and just write it as x squared over 16 minus y squared over 9 equals 1. All right. So let's think about the equations of the asymptotes. All right. Well, if I'm centered at the origin, right, it's fairly easy to think about the slope. Right. So if I'm centered at the origin, I know we're thinking about y equals mx plus b for the equations of these lines, I know my b value will be 0. So really all I need is the slope. Well, if we think about, if I look at that last example, the slope of each of these lines, how far up and how far over I go, well, I went up 3 over 4. So all I'm doing is taking the square root of the denominator over the square root of the denominator, right? Which ends up being just, if I'm thinking about both asymptotes, right, the slope of one of them is positive, the slope of the other is negative. So it's just going to be the square root of whatever the y value is over the square root of whatever the x value is. So usually we would write that as y is, underneath y is the b, and underneath x is the a value. All right. So in terms of these examples, my asymptotes will be y equals plus or minus, oops, I forgot my x there. The square root of 9 is 3 over the square root of 4 is 2. I'm just taking the change in the y over the change in x. So for this one, I forgot my x again. We'll have y equals plus or minus the change in y over the change in x. So the equations of those lines are y equals positive 3/4 x and y equals negative 3/4 x. Okay, now if we have our equation centered at another point, okay, these will still be the slopes, okay, but we would have to do a little bit more work to find the actual equations of the asymptotes. Now, if we do have centered at HK, okay, the equations of the asymptotes will be y equals plus or minus b over a still, right? We're still taking the change in y over the change in x, but then we'll just have to account for h and k, okay? So this would be the equation, or these would be the equations of the two asymptotes if we're not centered at the origin, all right? So a couple more examples. Here we have a hyperbola centered not at 0, 0. Here we're centered at, now we have to be careful, okay, my x coordinate is over here with the x, and my y coordinate is over here with the y. So I would be centered at -3, +1. Now this hyperbola is going to open up and down because my y is what's positive, right? So we're opening up and down. And we already said the center was at the point -3, 1. Now, to make my box, I'm going to go up and down 2. Okay, now, whoops, I went one too far. Now these, since my hyperbola is opening up and down, these are the vertices. And then I'm going to go 3 to the right in either direction. So this is my box. I want to make my asymptotes go through the diagonals. And then I can sketch my hyperbola. Okay, so these are the vertices. So it's going to do something like this. This one's going to be much wider. Right, so I would just follow along those lines there and there. All right, and then finally our vertices. Let's see, those are at the points -3, +3, and -3, -1. All right. So this question didn't ask for this information, but we could still find the foci as well. All right, so I'm going to actually add that on here. To do that, we're using this a² plus b squared equals c squared idea. So I'm going to have 4 plus 9 equals c squared. So 13 is equal to c squared. So c is the square root of 13. And remember, c is the distance from the center to each foci. So from here, I would go up the square root of 13 and down the square root of 13. So the square root of 13 is it's like 3.5-ish, 3.6, something like that. So I would go up about to there and then down 1, 2, 3, about to there. So there's where my two foci are. And then to write those coordinates, x is still at -3, but then I would be taking this y coordinate plus the square root of 13, so 1 plus the square root of 13, and then -3, 1 minus the square root of 13. All right. So one more example. We want to put this into standard form. So yet again, just like we've been doing, I need to complete the square here. All right. So I need to collect all of my x terms and collect all of my y terms. So I'm going to have 9x squared plus 18x. I know I'm going to have to add something in there. Now, this part can get a tiny bit tricky, right? If I'm bringing my negative sign outside of the parentheses here, my 16y squared would be positive on the inside. And then if my 64y was positive, it'll become negative. Okay, if I'm factoring out a negative sign outside of the parentheses, I'm essentially changing the sign on everything that was on the inside, right? Because if I distributed this negative sign through, we would have negative 16y squared, and we would get a positive 64y. Right? So then plus something equals, now I'm going to add this 199 over, and then I know I'm going to have two blanks over here. So now, again, remember we need to have 1s as our coefficients, so I'm going to factor a 9 out over here and make this 9 times x squared plus 2x plus something minus, and I'm taking a 16 out here, so minus 16 times y squared minus 4y plus something equals 199 plus something plus something. So now we complete the square. Take half of b and square it. So half of 2 is 1. 1 squared is 1. So I'm really adding 9 times 1 to this side. So I'm going to add 9 over here. Do the same thing here. Half of -4 is -2. -2 squared is 4. But I'm really adding -16 times 4. So -16 times 4 is -64. All right, so now this factors into x plus 1 squared minus 16 times y minus 2 squared equals, what do we get over here? 208 minus 64 gets me 144. So now, final step, get a 1 over here on the right side. So to do that, I need to divide everything by 144. So 9 over 144 would reduce to 1 over 16 minus 16 over 144 would reduce to 1 over 9. So this will be y minus 2 squared over 9 equals 1. Okay, so the only difference or potential tricky part that's different from an ellipse is when I add this 4 in, I multiplied it by negative 16, so you need to make sure that you're taking this sign into account. So on the right side of the equation, I added negative 64 then. All right. So I do also want you to complete the homework over Thanksgiving break. Send me any questions that you have.